Namaskar. Valence bond theory was first put forward by Hitler and London in 1927. They gave a theoretical treatment to explain the formation of a covalent bond and energy changes taking place in hydrogen molecule. This theory was further extended by Pauling and Slater in 1931 to account for the directional characteristics of covalent bond. Let us try to understand the energy changes taking place during the formation of molecule like that of hydrogen molecule. Consider two H atoms are lying at a very large distance from each other. When they come close there are few attractive forces which act upon while there are few repulsive forces. Similar charges proton and electron repel, while electron and proton attract. As hydrogen molecule is formed we can say that attractive forces dominate. Let us label these hydrogen and electron for further explanation. For understanding purpose let us consider hydrogen atom A is associated with its electron label as 1 and hydrogen atom B is labeled with its electron 2. The wave function of these electrons can be written as psi A1 and psi B2. If hydrogen-hydrogen bond is formed then resultant wave function is psi is contribution of two individual wave function of hydrogen atom. A graph of energy and the internuclear distance can be drawn to understand this, which serves the basis of potential energy diagram for the formation of hydrogen molecule. When the two H atoms are at a very large distance from each other, there is no interaction between them, the energy of the system is close zero, and when the atoms are brought closer and closer to each other, the energy of the system starts decreasing and the energy becomes negative till a certain minimum value is reached. This curve shows that this minimum value is obtained at 24 kJ per mole, which is obtained at internuclear distance equal to 0.90 Armstrong. But when experiments were performed this value of energy that is 24 kJ per mole is very low when it is compared with the experimental value which is equal to 458 kJ per mole as an internuclear distance equal to 0.74 Armstrong. Can you calculate the radius of hydrogen atom from this data? Since the difference between the experimental value of energy and bonding energy obtained is 434 kJ per mole, the wave function given by the equation is not the correct wave function for hydrogen molecule. Thus in order to get the correct or at least close values we need to consider new wave functions. As we consider that this is covalent bond, we have not considered the influence of proton of one hydrogen atom on electron of other hydrogen atom. As when covalent bond is formed the exchange of electron is possible. According to this wave function hydrogen molecule has been represented as HA in which electron 1 has been supposed to be solely associated with nucleus HA and electron 2 is associated with nucleus HB. This assumption is incorrect, because when two H atoms come closer to each other and a bond is formed between them, electrons 1 and 2 have equal opportunity and freedom to get them associated with any of the two hydrogen nuclei. Thus, in order to get the correct wave function of H molecule, the following both covalent structures of this molecule should be considered. Where we have a new wave function. As evident from curve obtained from new wave function, the energy of hydrogen molecule is calculated to 303 kJ per mole which is obtained at an internuclear distance of 0.80 Armstrong. We should note that this is considered with combination of two wave function symmetric way. So there is a possibility of asymmetric combination of wave function. This leads to increase in energy and the system becomes unstable. However, this wave function we can ignore as bond will form when their wave functions are added in a symmetrical manner. As still there are other points for us to consider we can further improvise the wave function. We can also consider screening of electrons. When the two hydrogen come closer, the electron of one atom shields the electron of other atom. When value of effective nuclear charge to improve the wave function we obtain wave function with minimum energy bonding energy equal to 365 kJ per mole at an internuclear distance equal to 0.76 Armstrong. The wave function can be further improvised considering ionic character in hydrogen bond. In ionic structure both the electrons can be associated with HA hydrogen atom or with HB nucleus. giving us a new wave function which considers both covalent and ionic character of wave function. The ionic nature shows an increase the force of attraction between the two hydrogen atoms. Here lambda is called the mixing coefficient or weighting factor and represents the magnitude of the contribution made by the ionic structures to the total wave function of hydrogen molecule. The value of bond energy is 388 kJ per mole, which is obtained at an internuclear distance of 0.75 Armstrong. This value 388 kJ per mole is much closer to the experimental value compared to -24 kJ per mole. This shows that when both the structures, namely covalent as well as ionic, contribute to the true structure of hydrogen molecule, that is, the true structure of this molecule is said to be something which is in between these structures. H and H bond in hydrogen molecule is covalent, and there is possibility that bond is partly ionic. Thank you.